Okay, we're talking about finding the area, and in this particular problem here we're going to be finding the area between two curves. And so what we're going to need to do here is we're going to be finding the area up underneath this curve first, and then we're going to find the area up underneath this curve, and we're going to take the larger area, subtract off the smaller area, and our difference is going to be what I've got shaded here in green. Okay, so you're probably wondering, why do I have this shaded yellow? Well, where these two shaded regions intersect, we said was green, and yellow and some other color. When you add them together, you get green. So this is yellow. Wonder what the other color is. But anyway, what we're going to be doing here is I've got it illustrated is we're going to be finding the area under that top curve first. So we're going to find the area of, well, I guess this triangle here first. And then we're going to find the area underneath this curve. And I've got it shaded as blue, and it looks to me like we're going from 0 to 1. So like I said, we're going to take the yellow area, we're going to subtract off the blue area, and what's going to be left with is the green area. Okay, so we're going from 0 to 1, and this was our straight line, and we're finding the area here of the yellow shaded region, and then we're going to subtract off, and then we're going to find the area of the blue region. Now look at this. The properties of integrals here, we've got the sum and difference properties. This happens to be the difference property. We can actually go ahead and join both of these together, where we get the integral from 0 to 1 of x minus x squared dx. Now this is really interesting, I find, when I was first learning this, is we had these two other separate curves. We had one that was a parabola, one that was a straight line, and now we've got something completely different here. Well, anyway, we went ahead and took the integral of it, and this is what we ended up with. Remember, we were going from 0 to 1, and so we plug in our upper limit into the integral and subtract off, and then our lower limit, and we get a total of 1/6. Now remember, this is square units, but we don't tack that on to the end. So that total area of that green shaded region is 1/6 square units. Now remember, what I said is we took the difference of those two functions and got a new function, and then we integrated between 0 and 1. Well, let's say that we graphed out that new function that we got. Well, this is the graph of the new function, and this looks completely different from our original problem. But it turns out when we integrate between 0 and 1 of this new function, which happens to be, this area happens to be 1/6. Now I've kind of got this blown up. This looks a whole lot, this shaded region looks a whole lot greater than the original shaded region. But anyway, so it turns out that our area here is 1/6, and we'll say square units.